One. Very good morning to one and all. This is Dr. Pranay Dute, and today we are going to see about the concept of plate tectonic theory and related theories to this plate tectonic. So I'm going to share my slide. So today's topic is interior of Earth, continental drift, and plate tectonic. Interior of Earth, continental drift, and plate tectonic. This is the topic for today's lecture. So we know that there is a there is a different sphere we have, like lithosphere, which is specifically a land part, a lithosphere, which is specifically a land part, also called as the solid part of the earth. Then you have a hydrosphere, which is the water bodies of the earth. Then you have a atmosphere, that is the air, right? Whatever the air you have in the earth. So you have a solid part of the earth that is known as lithosphere. Hydrosphere is the liquid part of the earth. Atmosphere is the air. So three different parts you have. Then earth interior, what how the earth interior is going to start. So you have the interior of earth. Maybe you have three to four different parts. Like interior of earth is you have a crust, mantle, and core. Crust, mantle, and core. So crust is oceanic and continental part. Crust is oceanic and continental part. Crust is below the ocean. Crust is below the ocean. Then continental is a crust that is made up of land. Then you have mantle, that is a liquid layer, magma, melted rock. Asthenosphere, that is a mantle, part of the mantle with convection current. Then you have outer core. Then you have outer core, liquid layer made up of the iron and nickel. Inner core, solid layer made up of the iron and nickel. Then what is the exactly meaning of the continental drift? What is the continental drift? Alfred Wegener theory that the continent were once a single supercontinent. Alfred Wegener theory that the continent were once a single supercontinent called the Pangea. That is all land are part of this one. Over time, this supercontinent slowly broke apart into what we have today. So, what is the evidences behind this continental drift theory? What is the evidences behind this continental drift theory? So, you maybe you may know about the puzzle game. Okay? You know about the puzzle, how the puzzle is started to look like. So, your continent can fit together like a puzzle if you join this all. If you join this all, you can see that this all are the just okay, these all are the just a breaking and what this puzzle is there, how the puzzle is there. The puzzle is nothing but a puzzle is nothing but a different part which is uh, in a different breakup, but when you can join it will be put together. That is your puzzle theory. Then you have a fossil evidences. Then you have a fossil evidences. A fossil evidences is what? So fossil evidences is a continent can a similar fossil were found on a coastline of different continent. So similar fossil were found on a coastline of different continent. That is your fossil part. That is your fossil part. Then you have a rock type. A different rock type, a similar rock type can be found on this side also on and found on this the opposite side also. So that is your rock type. So you have a puzzle. You have a puzzle of continent can fit together like a puzzle. Then you have a fossil. Then you have a rock type. Puzzle, fossil, and rock type. This is the three different evidences we have. Then you have a plate tectonic. Then you have a plate tectonic. So theory of plate tectonic is nothing but the when you have a different plates. When you have a different plates, the theory of plate tectonic, the crust is broken up into the section pieces that move on the top of the liquid mantle that is known as the asthenosphere. So you have a lithospheric plate, you have a lithospheric crust, Then inside this lithospheric plate, you have a asthenosphere. Okay, you have a asthenosphere. So mobility of this asthenosphere is make a major part on your lithospheric plate. Then you have a tectonic plates. Then you have a tectonic plates. This section pieces of crust are called the plates. This section pieces of crust are called the plates. Then you have a different plates. You have there is a seven major plates on the earth. There are seven major plates on the earth that are moving extremely slowly but continuously. So we have a major plate like Eurasian plate, African plate, Australian Indian plates, North American plate, Pacific plate, Antarctic and South American. So this is the different plates, major plates we have. Then you have intermediate plates like Caribbean, Cocos, Nazca, Arabian, Philippines. So this is the different plates we have, different plates we have between this one. Two main type of plates. There is a two main type of plates. You have oceanic plate and continental plate. There is a two main type of plates. One is oceanic plate and one is continental plate. So this is how your Earth tectonic plate is looks like. This is how your Earth tectonic plates is looks like. Then you have a convection current. How the convection current is rises and how the convection current theory is going to be a part of this one. So convection cell is in the mantle move the plates. Convection cell in the mantle moves the plate. Hot in the center, less denser magma rises up due to the heat. When the magma reaches the surface, it cools and sinks back down, creating a circular pattern of movement. This process happens continuously. And that is how it is called as a convection current theory. That is called as a convection current theory. Okay. So you have a two plates, that is oceanic plate and continental plate. You have a two plates, that is oceanic plate and continental plate. So oceanic plate is a more dense, whereas your continental plate is a less dense. Okay, your oceanic plate is a more dense, your continental plate is a less dense. Then you have different plate boundaries. Different plate boundaries. You have what kind of plate boundaries? A divergent plate boundary, a divergent plate boundary, a convergent plate boundary, a divergent plate boundary, and a convergent plate boundary we have. So, divergent is nothing but so if there is I can take an example of I will take the example of any of the two things which I have right now. I have a mouse and my mobile in my hand. So like this two is having two different plates. This is a two different plates we have. This is the two different plates we have. So when these two plates get away from each other, when these two plates get away from each other, this one is known as the divergent plate boundary. When these two plates get away from each other, this is known as the divergent plate boundary. When these two plates is coming together, that is known as the convergent boundary. And when these two plates are going relative to each other, that is known as the transform plate boundary. So this is how your different plate boundaries are there. So your divergent plate boundaries, when the plate boundaries is moving apart, that is known as the divergent plate boundary. When the plate is moving apart, that is known as the divergent plate boundary. Then when your plate is coming together, that is your that is convergent plate boundary. That is known as your convergent plate boundary. So divergent and different kind of boundary and what kind of boundaries we have. Then seafloor spreading. What is the seafloor spreading? The process by which new oceanic crust is created. The process by which new oceanic crust is created. Two oceanic plates move apart from the magma that is comes up. As the rising magma cools, it forms a new oceanic crust. Then you have a magnetic reversal. Then you have a magnetic reversal. So evidences of seafloor spreading. Evidences of seafloor spreading is what? That you can have a reversal and a normal magnetism. So you have a youngest crust is in the center, oldest as you go out. Youngest crust is in the center, older as you go out. Earth magnetic poles reverse from the north to south. Earth magnetic poles reverse from the north to south. So we have a mid-oceanic ridges. We have a mid-oceanic ridges, a mountain under the ocean. So we have a mid-oceanic ridges, that is a oceanic plates we have. So in a mid-oceanic ridges we have two oceanic plates. When two oceanic plates are there, we can have the divergent plate or oceanic crust can go away and form a mid-oceanic ridge. A mid-oceanic ridge forms where the oceanic plate continue to separate. Means on a divergent plate boundary you find a mid-oceanic ridges, a rift valley. So this is a different kind of this is nothing but a different kind of things which we study, and also the means which type of bodies and which type of things can be found on which kind of environment, that is, and which means on a divergent plate boundary what can find, on a convergent plate boundary what can find. So this is how you can have different kind of things. So then we have you have a rift valley, that is when you have a continental collision. When you have a continental collision, that is you known as the rift valley. When the continental plates pull apart, they form a rift valleys. When the continental plates move apart, they form a rift valley. It makes a volcano and new lands. When the continental plates move apart, they form a rift valley, which makes a volcano and new lands. Then what is the convergent plate boundaries? What is the convergent plate boundaries? So when you have two plates which can join together, when you have two plates which can join together, that is known as the convergent plate boundaries. That is known as the convergent plate boundaries. Then you have a subduction zone. Then you have a subduction zone. When one plate goes under the another plate, when one plate goes another under another plate, that is known as the subduction zone boundary. That is known as the subduction zone boundary. The more dense plate goes under, the more dense place goes under. Then you have a volcanic arc. Then you have a volcanic arc. So more dense oceanic crust. So more dense oceanic crust goes under the less dense continental crust. More dense oceanic crust goes under the less dense oceanic crust, continental crust. As the plate move under the continental plate, the rock melts and rises, creating the volcano. Trenches are also created. Then you have a deep sea trench. Then you have a deep sea trench, a depression in the ocean floor at the subduction zone at its sand it is in. Then you have volcanic island chain. Then you have volcanic island. Two oceanic plates meet, one goes under and another. This forms the volcanic island. So we have a different kind of these theories. Then you have a mountain, how the mountain is formed. So when the two continent get together, when the two continent get close to one, that mountain is called as that is called as a continental continent. So Himalaya is a best example for this one. The plates push up and form the mountain. The plates which is push up and form the mountain. Transform fault boundaries. Transform fault boundaries. So plates slide past one another, moving in opposite direction. Plates that is slide past one another and moving in opposite direction, that is known as the transform fault boundaries. Also called faults because it causes the earthquake and tsunami in the areas. The plates slides past one another, moving in the opposite direction. which also called a fault, which causes the earthquake tsunami to occur. Then you have a fault. Then you have a fault. So what is the fault? Fault is nothing but a displacement. Fault is nothing but a displacement of the rock block along the any plane. Displacement of the rock block along the any plane, that is known as the fault. Then you have a different type of fault. Then you have a different type of fault: normal fault, reverse fault, and strike slip fault. So what is the fault? Fault is nothing but a displacement of rock block. A fault is nothing but a displacement of rock block, whereas your normal fault is, and this all are the relationship with the this normal fault, and this one is relationship with the your this one fault. So an opening in the earth that erupt gases. So volcanoes are what? Volcanoes are known to be when you have opening in the earth in a volcano, in opening in the earth which erupt the gases, ash and lava. Opening in the earth that erupt a gases, ash and lava caused by the plate movement along the boundaries, causes at the both divergent and convergent plate boundaries. So you have two different particles. You have one is known as the magma. Now, what is the magma? Magma is nothing but material from the earth, a molten material from the earth which comes out the surface. That is your known as your magma. It is a melted rock under the surface. That is known as your magma. It is a melted rock which is comes from the under the surface. That is your magma. Then you have a lava. Then you have a lava. Lava is nothing but a melted rock above the surface. Lava is nothing but a melted rock above the surface. That is your outside the surface. Then you have a shield. What is a shield? Shield is a volcanic cone made up of layer of hardened lava. Volcanic cone made up of layers of hardened lava. That is your shield. Then you have a cinder cone. Then you have a cinder cone, a volcanic cone which is made up of the rock particle, dust and ash. A volcanic cone made up of the rock particles, dust and ash, which is known as the cinder cone. Then you have a composite volcano. Then you have a composite volcano. So volcano cone made up of the alternating layer of lava and rock particles. Then you have a hotspot. Then you have a hotspot. Hotspot is a part of mantle. Hotspot is a part of mantle that is really hot, and magma is forced up to the surface, which creates the islands. Which creates the island. So hotspot is nothing but a part of mantle which is really hot, and magma is forced up to the surface. That is known as your hotspot, which create a island. Then you have a earthquake. What is mean by earthquake and how the earthquake is going to? So you have a earthquake which is caused by the movement along the fault. Earthquake is caused. It occurs mainly. It occurs mainly at the your plate boundaries. It occurs mainly at the plate boundaries. So we have a different sphere. Okay, we have a different sphere like lithosphere, hydrosphere, and atmosphere. We have. So this all are nothing but these all are nothing but a solid part of the earth. Hydrosphere is a liquid part of the earth, and gas atmosphere is your what you can see above the earth. Above the earth. So that is known as your hydrosphere and atmosphere. So now interior of earth means the material is inside the earth. What material is interior of earth. That is known as the interior of earth. So you have a crust, mantle, and core. Okay, you have a crust, mantle, and core. Then you have continental drift. What do you mean by continental drift? Alfred Wegener theory, that is the continental where once a single supercontinent called Pangea. Alfred Wegener, which is Alfred Wegener theory, which is a continent where once a single supercontinent called a Pangea. Over this time, supercontinent slowly broke apart into what we have today. Then we have different evidences for this one. We have different evidences for this one. Like you have a puzzle, like you have a puzzle, that is your continent can fit together like a puzzle. Okay, if there is a all continent are in a different side, we can take as a puzzle. Then you have a fossil, that is a similar fossil were found to be on a coastline or a different continent. Then you have a different rock type. Then you have a different rock type like mountain that appear on the coastline, which also appear on another constituent across the ocean. So theory of plate tectonic is suggested what? A theory of plate tectonic, that crust is broken up into the section pieces that moves on the top of the liquid of mantle. Okay, this section pieces of crust are called the plates. There are 7 major plates on the earth that is moving extremely slowly but continuously. That 7 major plates which is moving extremely but slowly and continuously. So major plates are Eurasian plate, African plate, Australian Indian plate, and North American plate. So this is a different major plates we have. Then we have intermediate plates like Caribbean, Cocos. Okay, like we have Caribbean, Cocos, Nazca, Arabian, Philippines, and this all. This is a different kind of plates we have. This is a different kind of plates we have. So this is a picture which show the earth tectonic plate boundaries. This is a what we can have earth tectonic plate boundaries. Then we have a convection current. Then we have a convection current. What is the convection current? So convection current is when there is a hot in the center. When we have a hot in the center, okay. When the magma reaches the surface, when the magma is reaches the surface, and it cools and sinks back down, the creating a circular pattern and movement. This process happen continuously. So when you go up, that is when the hot is there, the magma is hot, you can go up. When there is a hot surface, you can go the up. The magma is go up. When there is a cooling is take place, when there is a cooling, you can have the what we can say the magma is goes down. So this is how your process is going to happen. This is how your process is going to happen. Then you have oceanic plates. Then you have oceanic plates, which is a heavy sink underneath the continental crust. You have oceanic plates, which is heavy sink underneath the continental crust. Then you have continental plates, that is a less dense and lighter. So you have a plate boundaries, a different kind of plate boundaries you have. Like you have a divergent plate boundary. So divergent plate boundaries are those plates which is goes away from each other. The divergent plate boundaries are those plate boundary which is goes away from each other. That is known as your divergent plate boundaries. Then you have what? You have seafloor spreading. So what is the concept of seafloor spreading? What is the concept of seafloor spreading? So seafloor spreading is nothing but a seafloor spreading is nothing but when you have in a sea or in ocean, means two oceanic plate coming like when the go up each other, and, uh, as magma cools, as rising magma cools, it forms a new oceanic, crust. Now, you have evidences of seafloor spreading. You have evidences of seafloor spreading. At the youngest crust is in the center, oldest you as you go out. Differences of seafloor spreading. When you have a youngest crust is in the center, old as you go out. Of my amount the dose is you know ocean plates. Mountain, when the continental plates pull apart, where the continental when the continental pull apart, make volcano a new planet. Makes volcano a new planet. Then you have convergent plate. Then you have another convergent plate. It comes together, plates together, whether it's continental or this one. This is known as a convergent. Whether continent, that is not the important. We then at you often have a subduction. And convergent plates often have a subduction zone that is known as the convergent plate. Goes under another plate, one plate goes under another. The more dense plate goes under, more dense plate goes under, then the lighter plate goes above the surface. Then you have a volcanic arc. Then you have a volcanic arc. So more oceanic crust goes under the less dense continental crust. More dense oceanic crust it goes under the less dense continental crust. The plate moves under the continental plate. As the plate moves under the continental plate, the rock matrix rises. The rock matrix rises and creating a volcano. And creating the volcano. Trenches are also being created. Trenches are also being created. A depression in the ocean floor, a depression in the ocean floor at the subduction zone it is having a sand in it. So when you have a depression in the ocean floor, when you have a depression in the ocean floor at the subduction zone it has a sand in it. Then you have a volcanic island chain. Then you have a volcanic island chain. When two oceanic plates meet and one goes under the other, that is known as a subduction. When two continental plates come together, the plates push up and form a plate. Then you have transform fault boundaries. Then you have transform fault boundaries. What is the mean by transform fault boundaries? So when you apply, plates are sliding from each other. When you have a plate that is sliding from each other, that is known as transform fault boundaries. Now, what is mean by fault? Fault is nothing but a displacement. Fault is nothing but a displacement to the rock block. Displacement of the rock block on a means if you have two rock blocks, they can displace to each other. So that is known as your fault. Then the different type of faults. We have a normal fault, we have a reverse fault, and we have a strike slip fault. We have a normal fault, we have a reverse fault, and we have a strike slip fault. Then what is a volcano? It is a volcano. An opening in the earth, which erupts gases, ash, and lava. Opening in the earth, which is gases, which ash and lava, and caused by the plate movement along the boundaries. It is caused by the plate movement along the boundary. That is known as your volcano. Volcano can erupt magma and lava. Volcano can erupt magma and lava. What if you have a different type of volcano then? You have a shield, volcano, then you have a cinder cone and composite. You have a shield, you have a cinder cone, and you have a composite volcano. You have a composite volcano. Then you have a hotspot. So hotspot we already study in one of the our previous lecture. What exactly important for the geology and so when all the entire Deccan trap is made up from the magma. Okay, entire Deccan trap is made up from the magma. It is to the hotspot. Then you have a earth. Then you have earthquake. Earthquake which is caused by the movement of the water. Earthquake which is caused by the movement along the water. Occur at boundaries. Occur mainly at trade boundaries. The focus and epicenter. Terms we use the focus and epicenter. The focus is the point. The focus is the point under the Earth surface where an earthquake starts. Focus is the point under the Earth surface where an earthquake starts. It is on Earth. It's the place on Earth surface directly above the focus. Then you have seismic waves. So we have a seismograph. Like seismograph is nothing but an instrument. Seismograph is nothing but an instrument which is used to measure a earthquake wave. It is used to measure a earthquake wave. That is known as your seismograph. So you have a type of wave that is a P wave, S wave, and L wave. So you have P wave, L wave, S wave, and L wave. P wave is the fastest one. P wave is the fastest one. S wave is the slowest one, and L wave is the most dangerous because it is a surface wave. Surface wave. Then you have tsunami. Tsunami, which is also called as tidal wave. Tsunami is also called as a tidal wave. It is also called as a tidal wave. Large ocean wave caused by the earthquake under the ocean. Large ocean waves caused by the earthquake under the ocean. Ocean flow moves along the fault